Your fingerprints are like your own built-in biological signature. Everyone has a unique set, from plain roll loops to tented arches to the minuscule bifurcations in between. Because of this, they work as great trace evidence in forensic science.
They are formed from the prenatal environment and the growth of the basal cell layer of the skin to create friction ridges.
So why are they useful in a crime scene? Because you leave them everywhere.
There are three main classifications: plastic, patent, and latent. Plastic prints are nice because they appear on soft surfaces as indentations. Patent prints are also great. They are prints formed when a material such as paint is transferred from a digit to a surface.
Then there are latent prints. These prints are common but tricky because they're invisible,
formed from the transfer of the body's natural oils and sweat.
While plastic and patent prints are easily photographed, scientists would get more creative with latent prints. There are countless methods for latent print development. You've likely heard of dusting from crime TV shows. It's common because it's cheap and easy.
It consists of brushing a fine powder on a latent print which will adhere to its aqueous and oily parts. This print can then be lifted off the surface with tape and contrasted against a new background for documentation.
Dusting is good for many reasons, but it's not entirely perfect.
It can only be used on non-porous surfaces and will not work well on dried out prints.
Considering that prints are approximately 99% water and that soon evaporates after print formation, dusting isn't always the best method.
For this, amino acid reagents are a good substitute. The most well-known is ninhydrin.
It's perfect for revealing latent prints on porous surfaces, like paper, even years after the print was made. This is due to amino acid's high affinity to cellulose, and the fact that it doesn't evaporate like water does. Ninhydrin reacts with those trace amounts of amino acids left over from the print to form a deep purple product nicknamed Riemann's purple.
How this works is that ninhydrin dissolved in ethanol is sprayed on the latent fingerprints. It will react with the amino acids through dehydration synthesis, which basically just means that water is removed to join the two molecules. The product is a Schiff base, which will then undergo decarboxylation, where carboxyl groups are removed and CO2 gas is a byproduct. Then, the molecule reacts with water, where the R group from the original amino acid is separated. This forms an aldehyde, which is underlined, and a diketohydrinamine. This molecule will then react with ninhydrin once again to form the final product, the Riemann's purple.
Don't get hung up on the specifics. Just know that the important part of this reaction is that the ninhydrin reacts with the amino acids to form Riemann's purple. Dusting and ninhydrin are just two examples of many ways that forensic scientists document latent prints. And prints are just one of thousands of kinds of trace evidence used to reconstruct a crime scene. Forensic science is a crucial addition to the legal world, making investigations quicker and more accurate. So you can thank science and your fingerprints for a safer world.